Alright, this is Precalculus, lesson R-2. Today's date is Tuesday, October 8th, 2019. So this is usually one of the last lessons in the rational unit, so it's one of the hardest lessons. So if you know what you're doing in this lesson, then you really have it down. Our objective today is to add and subtract rational expressions, obviously, but they are not factored and don't have common denominators. So all of that is the reason that it makes this really hard. All right, I've broken it down into 4 steps. First, factor out the greatest common factor in both the tops and the bottoms. Usually you'll only have it on the bottoms, but whatever. Maybe underline bottoms, that's usually the one that you're going to have to factor. Step number 2, use Ninja Star. I should be saying advanced Ninja Star, I suppose here. We'll say advanced Ninja Star on quadratics to factor. So I would say on maybe a quarter of them, they're going to be quadratics, so you'll need a Ninja Star. A lot of these are just factoring out GCF and you're done. And then step number 3 is to multiply by the missing bottom terms to make sure you have like denominators. So you can make a note here. The reason you're doing this is for like denominators. And then finally just combine the like terms to simplify. Just add the tops, right? All right, so here we go. Example 1. These are mega problems, so we're going to be 2, and then we'll be done, and hopefully have enough time to finish in class, and hopefully the power does not go out. So step number 1, factor out the greatest common factor. So I'm going to rewrite this fraction. On the bottom, we have the greatest common factor in terms of 10 and 60 looks to be 10. And in terms of the variable x to the power of 4, x to the power of 3, you always just choose the smallest one. So it's going to be x to the power of 3 in this case. X to the power of 3 is factored out. And when I do that, 10 divided by 10 is 1. So leave it, and x to the power of 4 divided by x to the power of 3, I subtract 4 minus 3 is 1. So it's just x, 1x to the power of 1, so just x. Alright, copy down the sign, it's a plus, and then 60 divided by 10 is 6. That's a bad 6. And then x to the power of 3 divided by x to the power of 3, they cancel out, so there it is. There's the factored bottom, and the top here stays 8. So far, so good. Give yourself some room here, because we're going to have to multiply by stuff. We're now going to subtract this thing factored out. So, this has 3 terms, and it's a 2 here. That tells me it's a quadratic. Sometimes you'll have to do a GCF into a quadratic. This one is just a pure quadratic, and it's one of the hard ones because it starts with a 3. If it starts with a number other than 1, you know you're doing advanced Ninja Star. I think the one down here, it just starts with a 1, so this is just a normal Ninja Star if you want to use that. This one is an advanced Ninja Star, so good review. Here we go. Let's do it off to the side. This is advanced. I cannot write advanced Ninja Star. Here we go. So I multiply these 2 numbers. The first and last numbers are a and c, and put it in the top. 3 times 12 is 36. So 36 goes on the top, making my star. The number that goes on the bottom is 20. And the top left and top right is this number, but without the exponent, so just 3x. 3x and 3x. From there, I need to ask myself, what times what is 36, but also adds to 20? And I just start listing them off. 1 and 36. Okay, no, that doesn't work. 2 and 18. Oh, that works. Okay. 2 and 18. And then the final step is to reduce your fractions. So this fraction can't be reduced. It's still 3x over 2. This fraction, however, can be reduced. This turns into 1x, or just x over 6. And those are my answers, 3x plus 2 and x plus 6. 3x plus 2 and x plus 6. And the top remains 3x squared. 3x squared. Again, make sure you have room to the right because we're going to be multiplying stuff by these fractions. That was step numbers 1 and 2. Number 1 was right there. Step number 2 was right there. We're on to step number 3. Multiply by the missing bottom terms to make like denominators. So what's missing on the bottom? Hey, look, both of them have an x plus 6. Cool, so what's missing? Well, therefore, this fraction on the left-hand side is missing a 3x plus 2. So let's multiply it by 3x plus 2. 3x plus 2 all over 3x plus 2. Again, you have to multiply the same thing by the top and bottom, because otherwise you're changing the value. Right now we're really just multiplying by 1. And this guy's missing a 10x to the power of 3, so let's come over here and multiply. I'm going colorful. We'll go 10x to the power of 3 all over 10x to the power of 3. Those are the missing terms. So now we actually need to do the multiplication. So in terms of the denominators, always just leave them factored. I don't want to multiply those three together. That sounds like way too much work, and I would never do that to you guys. That's just cruel and unusual punishment. So the denominator stays the same. The denominator is just 10x to the power of 3 times x plus 6 times 3x plus 2. And note that the order of these doesn't matter. I could have put x plus 6 first. All right, and technically we have like terms, but I can go ahead and copy and paste this if I need to. That was a bad line. What's a better line? All right, so there's my fraction. I'm going to copy and paste you. Sorry, you guys have to rewrite it. And then there's this minus sign that's going to be annoying. Now I have to distribute 8 times 3x plus 2. 8 times 3 is 24x, and 8 times 2 is 16, so plus 16. And then I have to multiply these together. 3 times 10 is going to be 30x to the power of 2 plus 3, which is 5. All right, and then I just need to combine them and copy paste. So this one now is going to be, this is pretty straightforward. It's just negative 30x to the power of 5, negative 30x to the power of 5, and then add all this stuff, plus 24x plus 16. Done. Not my best box. I can redraw that, make it look a little bit nicer. Cool. What I want you guys to try right now is do example number 2 on your own. See if you can get it. I really want you guys to try this on your own. Even if you need a hint, watch up to the hint and then keep going on your own. That shows that you have a growth mindset. Alright, so now that you've tried to play with this, maybe you got all the way, maybe you got stuck, here's what we're going to do. We're going to factor. So on the left hand side here, I see that 14 goes into both of these terms. I see 1, 4, and then I added them to get the center of 5. So I know that I did 11 times 14. So 14 is the greatest common factor for the coefficients. For the variable, it's going to be n to the power of, choose the smallest one. That's the smallest one, n to the power of 2. When I factor out 14 n to the power of 2, I'm left with an n, and that's going to be minus 11. So far, so good. And then 5, you stay up there. Again, give yourself some room. Plus, and then this is going to be a normal ninja star. You can use an advanced ninja star. It'll still work, but normal ninja star is faster. So this is going to be a normal ninja star. A normal ninja star works like this. There's no center line, nothing like that. It's just like this. And I don't even worry about this because 1 times negative 33 is still negative 33. I just take this last number, stick it up top. That is not 33. There's 33. And the bottom number, negative 8 on the bottom. Let me get rid of that. Alright, so from here, we need to figure out what multiplies to 33 and adds to negative 8. So we know that we're going to have some sort of negative. The bigger one needs to be negative because the bottom is negative. So start listing factors of 33. 1 and 33. It doesn't work. 3 times 11. Oh yeah, that'll work. So 3 and 11. And then the bigger one needs to be negative. There's our answer. So if I come back over here and I make my fraction, this is going to be n plus 3 times n minus 11. And hey, check that out. N minus 11 n minus 11. That's one less step that we have to do. So what are we missing on this fraction? I guess I should rewrite this for n while I'm here. On the left fraction, we're missing an n plus 3. So let's multiply it by n plus 3 all over n plus 3. And I kind of want to make all these steps green to distinguish it from the original steps. And on this one over here, we're missing a 14n squared. So a 14n squared, 14n squared. Cool, cool. Now we need to multiply these. We're on step number 3. Multiply them over. So the bottom is going to stay the same. Here's the bottom. I'm feeling like red right now. The bottom, the denominator, is going to be 14n squared times, that's not my best n minus 11 times n plus 3. Alright, and what is our numerator? What is our top? Well, at least in this case, let me copy and paste this to save some work for me. At least in this case, I'm going to do 5 distributed into that n plus 3, so 5n plus 15, 5n plus 15, copy down the plus sign, and 4 times 14, what is that going to be? 4 times 4 is 16, so carry the 5, or carry the 1 and turn it into a 5, so 56, n to the power of 1 plus 2 is 3, that's a bad 3, and don't forget the same denominator, there it is, and then I just add them. So again, same denominator, it's just leave it in factored form. Our final answer now is, sure, I didn't mean to make that black, but I guess we're going to switch to black. It's going to be 56 n to the power of 3 plus 5n plus 15. And there's our final answer. Good luck on the notes, and hopefully you guys have power for the rest of school. I have my fingers crossed for you.